Hey, chemistry!
Hey friends, we're going to go over the 3.0 questions from our review notes from in class today so that you have some insight into what you might see on the test. So here we have learning target 131, a complex model. And you're asked to create a particle model in this beaker that represents a density of 0.75 grams per milliliter.
So the best way to think about this is remember that density is equal to mass divided by volume. So we have 4 different volumes you could choose from, right? 10 or 20 or 30 or 40. And so in this particular case, we said that the density is equal to 0.75, and then that's grams per milliliter. So we need to know how many grams and how many milliliters we need to draw on our diagram. So the way I like to think about this is when I'm giving a fraction, 0.75, okay, that's the same thing as saying 3/4, right? So 3/4 or 3/4. So 3 grams per every 4 milliliters. Well, over here, we don't have it measured in ones, we have it measured in tens, so that would be the same thing as saying 30 grams in 40 milliliters, which is something that we do have and are able to draw there. So the most important thing is make sure that you mark your volume. So Mr. Sanford just drew 40 milliliters to show his volume of 40. And then go ahead, what are you going to do for your particles, Mr. Sanford?
So the key says every particle there represents 1 gram, and I need 30 grams. So I'm going to draw 30 different particles in this particle model. All right, so there we go. That is one way you could have solved this.
So you can see that we have 40 milliliters, and we have, we have 40 milliliters, and we have 30 particles for 30 grams.
So if you take that and take your 30 grams and divide by your 40 milliliters, you will get a density of 0.75 grams per milliliter.
Also, keep in mind, we could have probably simplified this fraction as well, and we could have done 15 grams in 20 milliliters, and that would also have been correct. So you could have just drawn the volume at 20 milliliters and drawn 15 circles in that area. Okay? Both answers would be accurate. So there are multiple ways often to draw the density. As long as mathematically they come out to the answer that we're looking for, we would mark it as correct. Okay, let's look at another one. Okay, another thing that you have to do for learning target 131 is round answers to the correct number of significant figures. So to do that, we have to remember our math rules. When we're multiplying or dividing, we're looking for the fewest or the least number of significant figures. And so one of the things we need to do is look at each of the numbers individually. So Mr. Sanford is writing our significant figure rules on the board. So leading zeros, like we see right here, so these are leading zeros, are never significant. So the zeros that are in front of our non-zero number, so those are not significant. The 9 and the 2, those are non-zero numbers, so they are significant. So that means that this number has 2 significant figures in it. When I look at 4,000, these are what are called trailing zeros, these 3 right here. Trailing zeros, when a decimal is present, okay, are significant. When there's no decimal, they're not significant. So we see here that this is a comma, not a decimal. So the 4 counts because it's a non-zero number. These 3 do not count because there's no decimal. So that means that this answer only has 1 significant figure. So we have one of our numbers with 1 significant figure. The other number has 2 significant figures. Our rule with multiplication is that our answer can only have the number of significant figures as the fewest. So our fewest is 1 sig fig. So I'm going to take my 3.68. I'm going to keep my 1. And then I'm going to have to round the rest, okay? So my answer is going to become 3, and then I'm going to round my 6 to 0, right? I'm going to, 4. Nice. Sorry, guys, brain. So the 6 next to the 3 tells me I need to round that up to a 4. And then what I'm going to do is replace my 6 with a 0. And so again, I keep the 3 up front. And before I write down the 3, I need to evaluate what number is next to it. I skipped that part for a second there. So the 6 is going to tell me to round my 3 up to a 4. And then I have to place the 0 here so that my 4 still means 40, right? But the 4 is in the tens place and not in the ones place. So Mr. Sanford will do the next one.
So we've got 2 more numbers that we want to evaluate the sig figs on. Here's 500.00. These zeros are all trailing zeros, and we see a decimal point like our rule says. So that means all of these zeros count. So the 5 and then each 0. So this is 5 significant figures here. And then we have divided by 2.00. Again, those are trailing zeros with a decimal, so they do count as significant figures here. And that's 2 sig figs. And so we want to round our answer based on that least, that's 3. Whew, it's been a long day, Miss Ullrey. 3 sig figs. So we need to round our answer to match the least amount of sig figs. So this number needs to be rounded to have 3 significant figures. Well, right now as it stands, the 2 and the 5 are significant, but this 0 is trailing, but we don't see a decimal. So right now it doesn't count. In order to make this count, I need a decimal in there. And so I'm going to take my decimal, and I'm going to move it 2 places. And in between the 2 and the 5, I use scientific notation when I do that. I moved it twice, so it's 2, and it's a big number, so it's positive. So when I put that decimal there, now all of these numbers count, including the 0. Now we have a trailing 0 with a decimal, so now I have 3 significant figures. Okay.
All right, so let's move on. So learning target 132, we should be able to interpret complex models. So let's take a look at one. One of the things that you would have to be able to interpret is going to be a graph. So we have a graph here where we've got volume and we've got mass. Okay, so mass over volume, if we're looking at the slope of this line, would equal our density of iron. So it says examine the graph provided. Because the density of iron is constant, doesn't change, what happens to the mass of the sample of iron as the volume is increased? So if we take a look, volume is down here on our x. So it's saying what happens as volume is increased. So I'm going to look and see where my numbers increase. So volume starts at 0, goes up to 3.5. So that's increasing volume. So I'm going to look and see what happens to my line as these numbers get bigger. And we can see that the value of the mass also increases. So what you would need to write is as the volume increases, so as the volume increases, the mass also increases. Okay? And so that would be our answer for that one. We're talking about the relationship and we're talking about both parts of it because it asks what happened with the mass as the volume increases. Good.
All right, let's look at the last question on our sheet. It is a 3.0 level math calculation, and there's a giant typo right there. It should say 133. Mm-hmm. So we've got a student that measures the mass of a Major League Baseball 5 times to get the following values. They're listed right here, all 5 of them. According to Major League Baseball, the accepted value for the mass of their baseballs is 142 grams. We want to calculate the student's percent error. So we have a formula where we calculate percent error. And it'll be provided on the test for you, but it's measured value minus the accepted value, all of that divided by the accepted value, and times 100 because it's a percentage. Now, measured values come from experiments, from measurements, and the student made 5 different measurements. Now, we can't put all those 5 numbers in there, so we have to find the average of these 5 numbers, and Ms. Ullrey's typing that on a calculator for us right now.
So the way that you get an average is that you take the numbers and you add them together. So 152 plus 148 plus 145 plus 144, or 141 plus 155. So we take all those measurements, we add them together. So the 152, 148, 145, 141, and 155, we add those together. And then we divide them by the total number of numbers. So there were 5 measurements that were made. So we're going to divide that by 5. So if we add these all together, it comes out to 741. And we're going to take 741 and divide it by 5. And we get 148.2.
So 148.2 came from measurements. That is our measured value. So when we calculate percent error, that's the spot in our formula where we plug it. Accepted value, which shows up twice, comes from the problem. We're told that MLB wants me to be 142 grams. So now we can use those numbers in our percent error calculation. Measured value, 148.2, minus accepted value, 142, in parentheses, divided by our accepted value again, 142. Remember, these two numbers should be the same every time. And then we multiply by 100. And we can use our calculator to solve for this, but let's not forget the order of operations. We've got to make sure we subtract first, then whatever answer we get, divide, and whatever answer we get times 100. And when we do that, what do we get, Ms. Ullrey?
We get 4.366197. So we're going to round that to all of our numbers have 3 numbers in them, 3 significant figures, so we are going to round that to 3 significant figures. So that's 4.37%.
All right. Okay, friends, let's make sure we get all of those answered. That assignment is due tonight on Google Classroom, and you have your Edulastic review guide to work on until test day, which is Friday the 16th. All right. Thanks, guys.
Thanks, guys.
Bye-bye.